Hello everybody. So we went through the first problem number 1 in the previous video. We'll be going through the second problem under normal friction in this particular video. So which is problem number 2 in your notebook. Problem number 2 in your notebook. Let me just read out the problem. A block of mass 20 kg is placed on an inclined plane subjected to an external force P parallel to the plane. So taking the inclination of the plane with respect to horizontal as 30 degrees and the coefficient of friction, which is mu, as 0.24, determine the value of external force P. Determine the value of external force P. This is the question. Let me explain the question first. You have an inclined plane in this way. You have an inclined plane with an inclination of 30 degrees. And just explain the question now. And there is an object which is being placed on this particular inclined plane. Object of mass or weight 20 kgs, mass 20 kgs. It's given in terms of kgs. Usually we have it in terms of newtons. So to convert Newton into kg, self weight is given as 20 kgs. 20 into 9.81 will give you the self weight of the block in terms of newtons, which will be 196 newtons. Which will be 196 newtons. So self weight is given as 20 kgs. So if it is given as 20 kgs, convert it back to newtons. Okay. So we have an inclined plane of inclination 30 degrees, and we have a block which is being placed on this particular inclined plane. Now, according to the given problem, we have an external force P. We have an external force P whose line of action is parallel to the surface. Whose line of action is parallel to the surface. Now, you have the value of mu as well. Mu is given as 0.24 here. Mu is given as 0.24. It will be given in the problem usually. Now, this is all about the given data and the question. Now, we are supposed to find the value of P. Find the value of this external force P. You're supposed to find the value of this external force P under two conditions. Under two conditions. As I mentioned earlier, here the external force is impending up the plane. It's going up the plane. Even though the external force goes up the plane, it's directed up the plane, it's not compulsory that it has to pull the body along with it. I mean, here the external force is impending up the plane. It's not compulsory that even the body should impend up the plane in the direction of external force. It can impend down the plane as well, even though the external force moves up the plane. Or if the external force has that capacity to pull the body along with it, body can move up as well. Now, here you have to find the value of P. You have to find the value of this external force P under two conditions. Under two conditions. This will be the first condition. Under two conditions. The first condition is when the body impends down the plane. Even though the external force acts up the plane, if the body impends down the plane, in this condition you have to find the value of external force P. In this condition you have to find the value of external force P. This is one of the conditions. And the second condition is when a body impends up the plane. When body impends up the plane in the direction of external force itself. Body can either go up or down. It can impend either upwards or downwards. It will not depend on the direction of external force. Here the direction of external force is up the plane. It's not compulsory that body should move in the direction of external force. It can move in the opposite direction as well. So when body moves in the opposite direction, it indicates that this external force is not sufficient to pull the body up. This external force is not sufficient to pull the body up. Since it is not sufficient, body moves down. So in this case, you have to find the value of P. This is the first case. And in the second case, the external force is sufficient enough. In the second case, external force is sufficient enough so that the external force can pull the body up. The plane. So these are the two conditions where body impends down the plane, even though the external force is directed up the plane. And the second condition is body impends up the plane and the direction of external force is also up the plane. Both are in the same direction. In these two conditions, you have to find the value of P. You have to find the value of external force P under two conditions. In the first condition, external force is not sufficient to pull the body up. In that particular case, you have to find the value of P. In the second condition, the external force is sufficient to pull the body up. So in the first case, value of P will be less, and the second case, value of P will be more. So in these two cases, when body moves downwards and when body impends upwards, irrespective of the direction of external force, it remains same. Body moves downwards. When body moves downwards, you have to find the value of P, and when body moves upwards, you have to find the value of P. These are the two conditions. When body, you have to find the value of P when body impends down the plane and when body impends up the plane. These are the two conditions. This is all about the given question, and to find will be P. So self-weight W is given as 196 newtons. It's originally given in terms of kgs. Convert it into newtons. Now let us start solving by following the same steps as we went through for the previous problem. So you have two conditions here. As you know, you have two conditions. Let us consider the first condition. Let us consider the first condition where body impends down the plane. Body impends down the plane. Body impends down the plane. Let me draw the drawing. If this is the inclined plane. This is the inclined plane of inclination 30 degrees. This is the body. This is the body. And let this be the external force P, which is unknown and which is to be found in this case when body impends down. Here, the body impends down the plane. Body impends down the plane. Even though the external force acts up the plane, body impends down the plane. So what is step number one? In step number one, you'll draw the coordinates. In step number one, you'll draw the coordinates such that the x-axis should always be parallel to the surface. Surface is inclined here. So x-axis should always be parallel to the surface. This will be the x-axis and corresponding to this will be the y-axis. Axis will be inclined here. Done. Step number one is done. In step number one, you'll draw the coordinates such that x-axis will be parallel to the surface. In step number two, you'll mark the self-weight. Self-weight will always act vertically downwards in this case. Self-weight W is equal to 20 kgs, 20 into 9.81, which will be 196 newtons. Which will be acting vertically downwards. Now, since it acts vertically downwards, here the coordinates are inclined, is it not? Coordinates are inclined. So since self-weight acts vertically downwards, self-weight makes some angle with respect to x-axis or y-axis. Self-weight makes some angle with respect to x-axis or y-axis. Now, how to find is the question. Now, here the x-axis is parallel to the surface. The x-axis is parallel to the surface, as you know. Now, if this self-weight, if the line of action of self-weight makes an angle with respect to the surface, the same angle should be made with respect to x-axis as well. These two angles should be same. Agree. So angle made by this line of action with respect to surface is equal to angle made by the same line of action with respect to x-axis because surface and x-axis are parallel. So this is 30. Since it moves vertically downwards, this is 90, 30, and this will be 60. Agree. 60 degrees is the angle made by the line of action of force, line of action of self-weight with respect to surface. So if the line of action of self-weight makes an angle of 60 degrees with respect to surface, line of action of self-weight should make the same angle with respect to x-axis as well. It should be 60 degrees. The inclination of self-weight with respect to surface should be same. If you want, I'll draw it once again. If this is the x-axis, I'll magnify and draw. If this is the x-axis and if this is the surface, both are parallel. This angle is given as 30 degrees. And your self-weight acts here. Your self-weight W acts here. Now, if this is 30, this will be 90 because it moves vertically downwards. This will be 60. Right? So if this is 60, this is the angle made by self-weight with respect to surface. Since surface is parallel to x-axis, if this is 60, even this angle will be equal to 60. This angle will be equal. What is this angle? This is the angle made by self-weight with respect to x-axis. That is what we have drawn here. Done. So we are done step number 2 as well. We have marked the self-weight. What is step number 3? Step number 3 is to mark the normal reaction. How should be the normal reaction marked? Normal reaction should be perpendicular to the surface and directed towards the body. Let me mark it as normal reaction NR. Now, After marking the normal reaction, in the next step, you'll be marking the frictional resistance. Now, how to mark the frictional resistance? Frictional resistance should be marked in a direction opposite to the direction of motion of the body. So here, this is the first case where body impends down the plane. Body impends down the plane. Even to the direction of external forces up the plane, body impends down the plane. So frictional resistance should be drawn or marked in a direction opposite to the motion of the body. So body moves down the plane. So frictional resistance should be acting up the plane. It will not, again I'll clearly define it, frictional resistance or direction of frictional resistance will not depend on the direction of external force. Remember this. It depends only on the direction of motion of the body. Here body moves down the plane. So frictional resistance should be acting up the plane, So frictional resistance can be written as mu into N, R, normal reaction. So mu is 0.24 here, as per the given data, it is 0.24 into N, R. So this is step number 4. In step number 5, what we will do, we will draw the free body diagram. In step number 5, we'll draw the free body diagram. This will be the x-axis, y-axis. So I have to reproduce only the coordinates and force. Here the coordinates are inclined. Let me remove the inclination and let me draw it straight. So when I remove the inclination and draw it straight, self-weight will be acting. Self-weight W will be acting. Will be acting in the third quadrant here. This will be W is equal to 196 newtons, and angle made by W with respect to x-axis will be 60 degrees. This will be 60, as we found this in the previous one. So normal reaction can be shifted to positive y scale. Normal reaction, this can be shifted to positive y scale. P comes here as well as F comes here. F can be straight away written as 0.24 mu into NR. So this is the free body diagram. As far as this particular problem is concerned, this is the free body diagram. Now we have to start solving. The problem. If you have drawn the free body diagram, step number 5 is also done. In step number 6, what you will do, you just have one alternative here. To apply the conditions of equilibrium. The first condition of equilibrium is the summation of Fx equal to 0. Summation of Fx equal to 0 is the first equilibrium condition. And in order to apply the first equilibrium condition, we have to resolve this force into its horizontal and vertical components. Horizontal component will be minus 196 cos 60, minus because it moves horizontally to the left. And vertical component will also be minus 196 sine 60. This is the only inclined force that we have. Summation of Fx equal to 0. Let us mark all the forces which moves in x direction. P plus F can be written as 0.24 into NR. Let me write it in the next step. So P plus F minus 196 cos 60 is equal to 0. Let me simplify and write it down. So P plus F can be written as 0.24 into NR, normal reaction, minus 196 cos 60 is equal to 0. This cannot be solved because it has two unknowns. So let me consider equation number 1. Now let me apply the second condition of equilibrium, which is summation of Fy equal to 0. So let us see. Here we have NR plus NR, which moves. NR can be written as N as well, normal reaction, minus 196 cos 60 is equal to 0. So NR can be for normal reaction can be found straight away here, which is 196 cos 60, which is 169.74. Newtons. You got the value of normal reaction. Now substitute the value of normal reaction in equation 1. Normal reaction in equation 1 to get the value of P. Final answer as 57.26 newtons. This is the final answer required. So when body moves down the plane, value of P will be 57.2 newtons. This is the value of P when body impends down the plane. We got the value of P. So similarly, we have to find the value of P when body impends up the plane, which will be the second condition. Body impends up the plane. So this is the first case or first condition where we found the value of P when body impended down the plane. The second condition will be body impending up the plane. Body impending up the plane. So what do you understand by this? When body impends up the plane, everything remains as it is. Everything remains as the only thing which changes is the direction of frictional resistance. The direction of frictional resistance. So when body moves up the plane, what happens to the direction of frictional resistance? It moves down the plane. Whereas in the previous case, when body was impending down the plane, friction resistance was directed up the plane. Here, the body moves up the plane, so friction resistance should be moving or acting down the plane. So, which will be F. Moving down the plane is equal to 0.24 into NR. This is the only thing which changes. So, when I change the direction of friction resistance, it changes in the free body diagram as well. It was earlier in the positive X scale, now it shifts to positive Y scale. Sorry, negative X scale. It will be F equal to mu into NR. It comes here instead of this. This is the only thing which changes. Everything else remains as it is. Everything else remains as it is. So here in summation of Fx, it is not plus F, it becomes minus F. Even here it becomes minus. It becomes minus F and it becomes minus 1. Then everything will remain same. You will get the same value of NR. So when you substitute the value of NR in equation 1, you'll get a different value for P. You'll get a different value for P, and that particular value will be 138 point. That particular value of P will be 138.3 newtons, 73. This is the value of P when body impends up the plane. So if you know how to solve the problem when body impends down the plane, body impending up the plane will be 99% similar to that. 99% similar to that. It will not change. The only thing which changes is the direction of friction resistance. When body impends down the plane, friction resistance will be acting up the plane, and when body impends up the plane, friction resistance will be acting down the plane. This is the only difference what it has. So this problem is very important. You have next problem number 3, where everything remains same except the external force. Here external force is parallel. Then in problem number 3, external force is inclined. Inclined. And all other steps will remain as it is, will remain same. So let me solve problem number 4 as well in the next video, in the upcoming video. Thank you.